impact soit réaliste, il faut que le coût disons, le coût de production, la tarification donc, de cette eau potable et agricole, destinée à l'irrigation donc agricole, il faut que le coût soit le plus bas possible pour que, comme j'ai dit, pour que l'utilisation de cette eau soit profitable, bien sûr, aux parties prenantes. Au niveau de OCP Greenwater, nous avons la forte conviction que, je dirais, la seule voie possible aujourd'hui pour que le coût soit le plus bas, c'est l'innovation. Mais l'innovation au sens le plus large, en termes de technologie, en termes de management, en termes de transport, en termes même de, je dirais, d'idées intégrées depuis la production jusqu'à la consommation. Donc pour nous, au OCP Greenwater, notre mission, c'est quand même produire de l'eau potable et industrielle pour quand même avoir un impact sur donc, les parties prenantes. Et d'où nous avons fixé un certain nombre d'objectifs qui concernent l'adoption des technologies innovantes à haut rendement, bien sûr avec le recours aux énergies renouvelables, avec maximum de récupération d'énergie, et puis une réduction du coût à travers l'excellence opérationnelle, la digitalisation et le développement de l'écosystème national, donc notamment pour les intrants, et puis un recyclage total des saumures et des productions de produits à forte valeur ajoutée, et puis la production de l'eau customisée, notamment pour l'agriculture, et puis la création de synergies avec les acteurs locaux pour minimiser le coût sur toute la chaîne de valeur. C'est la raison pour laquelle nous avons lancé un certain nombre de workstreams, des initiatives de recherche et développement avec l'Université Mohamed VI Polytechnique et d'autres partenaires pour chercher donc, les technologies les plus innovantes et qui assureront donc, les coûts les plus faibles. Nous avons aussi lancé des études stratégiques avec GESA pour scanner à travers tout le monde quelles sont les technologies aujourd'hui les plus efficientes et qui sont matures et qui peuvent bien sûr créer de la valeur dans notre programme. Et aussi nous avons lancé des partenaires stratégiques avec des opérateurs, je dirais, qui opèrent déjà dans le domaine pour essayer de capitaliser sur leur expérience. Et tout ça, nous voudrons à ce que nous captons les meilleures idées pour les appliquer dans ce que nous sommes en train de faire, de telle façon à ce que nous pouvons réaliser des coûts intéressants et qui seront profitables, bien sûr, pour les consommateurs. Pour le reste donc, de cet event, je demande disons, à nos partenaires stratégiques, GESA, Exchange, SAICEM et Flotec, de partager avec nous donc, leur avis sur le sujet. Et merci.
Merci Ahmed. Donc vous l'avez bien compris, non seulement OCP Greenwater engage un important programme d'augmentation de capacité pour la production de l'eau à usage industriel et à usage aussi eau potable, mais il engage aussi plusieurs efforts d'innovation sur plusieurs verticales présentés par Ahmed Znebar. Et aussi, il a soulevé que l'un des partenaires stratégiques, c'est GESA. Donc, je demanderai à M. Abdelilah Bouziane d'exposer les différentes actions, travaux, stratégies relatives à l'innovation. I switch in French. I'm so sorry. Yeah, just one slide. This is.
In English. Thank you, Lamia. Hello, everybody. So, as Mr. Zneber mentioned, innovation is, is at the heart of our strategy and vision at GESA, is even the essence of our growth. So I had the privilege 2 years ago to, to create and lead this innovation, entity within GESA. And today, with the water program, we are working on a lot of streams to make sure that we are capturing all lessons learned, but also we are putting in place, all innovation streams and ideas that will let us or enable us to, achieve and execute the program with cost-effective and also with technology, advanced technologies. So here I would like to present briefly on the whole blockchain, the main, innovative, actions that we are launching with OCP, with UM6P also to execute the program of desalination. So on the upstream part, on very upstream part, we are working on intake facilities to monitor, to better monitor, all the input from seawater. As we discussed yesterday, there is a lot of perturbation when we have swells coming, and also very, very, aggressive swells that we have been, facing this past month. And today we are putting in place monitoring system. We are also launching, offshoring intakes to make sure that we are minimizing the impact of seawater and its perturbation. In terms of pre-treatment, we are. This is among the main block or among the main steps that allow us to have good, rate of permia. So we are working on both Safi and Jadida to put in place the right, solution for pre-treatment. We have been working with our partners present here to put in place some, new technologies like ceramic ultrafiltration that we are now executing at Safi site. We are working also with SciChem on the integrated UF, what we call IUF, and maybe Igor will elaborate more on these new technologies. On the desalination itself, so here where we have, space for energy recovery as well as for permia conversion. So we are working to put in place more, efficient devices when it comes to pressure exchanger. So we are working with ARI as well as with FlowServe to put in place, devices that can, give more efficiency in terms of energy. We are targeting 98% today. And we are working also on advancing, system for pumping. So we are thinking to put in place with our partner some solution to have pumps even on the brine side to minimize the brine and also improve the recovery rate of permia. So today, just for your information, the recovery that we have is around 40–45%. We are targeting to have more than 50% by integrating, systems, pumps on the brine, and by minimizing also the brine on the reject. So this is something that we are also working on and will allow us to have more efficiency either on energy or on the permia conversion. On the brine management, as I mentioned maybe yesterday, we are working on a recycling solution, either on seawater or on brine. In OCP side, and this morning when I was hearing from the last panel that the brine, whatever we do, the brine is an issue. Today for OCP we have a huge capacity of seawater used for the process, and we are using now the brine to be diluted in this basin of OCP, and by doing this we are even recycling this dilution or this quantity volume of brine with seawater to re-inject it again in the system. And we are also working on recycling seawater, because we don't want to invest more on seawater facilities. We have seawater coming from OCP processes that we can recycle and that we can re-inject in our facilities. This is some solution and some insight that we are now working on to have this brine management efficient on our facilities. And of course, we are working on the zero liquid discharge. It's the concept of circular economy for us. So we are working to maybe in the near future to have membrane with zero liquid discharge technology, which allow us to improve this, this aspect. In terms of post-treatment on the downstreams, the post-treatment for potabilization, we have also some insight to, improve the treatment here, and also to use as much as we can the sulfuric acid in replacement of CO2. CO2 today is the issue of CO2, even it's cheaper than sulfuric acid, but the issue is availability of CO2. Sometimes we have issue with CO2, and this will cause disruption of our production. And to avoid this, and knowing that sulfuric acid is a byproduct or material in OCP facilities, we are now trying to use more and more sulfuric acid to overcome this issue. And also CO2 is becoming more and more expensive compared to last years. So this is something that also we are working on to combine and use and leverage the acid, the sulfuric acid that we have in OCP facilities. And last and not the least, we are working on innovation, on innovative ideas for delivery and digitalization. So we have been taking the desalination project, the wave 2, that is ongoing now, as a pilot for digitalization, using smart design, using also some other, let's say, digital twins, and also working on advanced work packaging and working on modularization. Yesterday we were talking about wave 1, where we use modules with size of 5 mld each. It was small size. Now we are moving to bigger size with 20 mld, 20,000 cubic meter per day. This is, we have already achieved the standardized smart design that we are aiming to duplicate for our facilities. Thank you.
Thank you, Mr. Abdelilah. So you understand that there is several areas of improvement. So as mentioned by Mr. Ahmed Zniber, today is also the occasion to listen to our strategic partner about their effort to have some kind of innovative solution to these issues. So I will ask Dr. Alex to come here and to share with us their thoughts.
Okay, the new one, the technical one. Yes. Thank you very much. It was really nice to see all the developments. Although we are working together, I think we need to exchange more information. So this event is very nice to see the vision and what you are doing. And I think that from what you are already presenting, we have a lot of parts that we can contribute. So today, I will directly also go to some innovation. For example, you are talking about sulfuric acid using for rehardening. I have to tell you that we are using 98% or almost 100% of the units in Greece are with sulfuric acid, exactly with the same problem If you have islands, you cannot move carbon dioxide. It is much more expensive. And we have developed a lot of methods how you use it and minimize it by blending the rehardening materials. So, for example, what it's your problem, it was our problem also in Greece. So we deal with it many years ago. So I'm moving again a little bit about what you already know, what we are doing. I'm focusing on the geo-exchange because this is also something that you already have. I was amazing that, of course, you said something very obvious for you, but it's not obvious in the rest of the world. That you are using the seawater that you are already using for your industrial facilities, and you are making desalination. That means that you are pumping only one time the water. Of course, you are losing some water, and then you can use the brine again back. So you have, but the infrastructure is there. You are pumping water, you are returning water, and this infrastructure is there. So this is another way to work. Is water can be used for all this, also for cooling. I'm sure that you are using also water for cooling. I'm sure that you are doing it in your premises also, industrial cooling. For heating, for potable water, refrigerators, everything. And why we can do that? Because if you use a chiller, if you use a heat pump, you can see that you can pump water in 22 degrees, more or less. You pass it from the cooler. The cooler will take the water to 27 degrees and provide water at 7 degrees at the other side, but also provide heat at 50 degrees. Now the more advanced heat pumps can produce in parallel 70 or 80 degrees. So you use the seawater, the temperature stored in the seawater, because the seawater is energy also. It is not only water. And you are using the heat pump. Heat pump is the future of energy saving, as it was, and what is happening now with the heat pumps is a breakthrough, like what happened with the ERI, the pressure exchanger. Because what is the difference of this heat pump with a normal heat pump with the air? Is the water. When you have a typical heat pump that you are, right now we're here in this building, how we have cooling? There is a heat pump somewhere, and this, with air, it is trying to take out the heat, okay? But what is the media that you are using for cooling, for cooling the heat pump? The air. The air out there is 30 degrees. It can be 35, it can be 40. What is happening? The heat pump needs much more energy because it cannot cool down easily. If you use the seawater, the heat pump will absorb 40% less energy, 40% less energy for the same result. So sitting here and cooling, if we had a reverse osmosis next to us and we install this heat pump, 40% less in their condition. What is the main load of a country like Morocco or Greece? Cooling. Cooling is the main electrical load, okay? And what you can do in parallel, you want also hot water for the people. You have hot water together. You have all the three. It's cogeneration. And you have all the infrastructure there. What is the most expensive part of this? The seawater pumping. This is the problem. You have the infrastructure ready. The rest is a piece of cake. It's just adding up an equipment. Okay, it needs some engineering. It's like the reverse osmosis. Sometimes they ask me, what is the most difficult part of the reverse osmosis? I'm a manufacturer, you know. I say the pumping. The pumping is the most critical part. It can create the biggest headache. And if you have the luck to have, you also told about it, the problems of the pumping. It's a big problem. It's the biggest problem. It can stop everything working. But if you secure a good quality pumping of water, of seawater, this is a priceless source. It is not only for water, it's for energy. So, you see, the saving, if you compare to oil, it can be even 70% in some cases. And that is because the efficiency is changing completely. If you make cogeneration, all the three of them, the saving is more than 80%. It is, as I said, it's 40% in cooling. Together with heating, you are going to 70%. 70% energy saving to the most critical loads, heating and cooling. So, the reverse osmosis, you know, and this is something that it's not, I apply this system, I design actually because this is how I started, I'm a design engineer. I designed this system for the first time 20 years ago in a hotel. Now we have more than 50 applications like that. Some of them are huge. I saw them yesterday. We have buildings of 50 floors that they are doing this. See the amazing thing. You have a heat pump, you are cooling, you are heating, you are doing anything you want, and you return back. And you will see the design is clever enough. You see that there are two heat pumps because you may need cool or you may need heat, so you don't cogenerate everything. With this system, you can see there, is a flexible system that you can adjust to any load. That means you want water, you want more cool, you want more heat. The flow will always go the way that it will secure the maximum efficiency. And this is our know-how as a company working on the water and energy nexus. And in this field, we are also leaders in European scales. We have the biggest examples of this kind of systems are existing actually in Greece. So I'm just saying some advantages, very low maintenance because no noise, the heat pumps can be, you don't need to be out to the space, you can heat them. You know, all the big hotels, they love this because you don't, the biggest problem is where you will put the chillers in the basement. You don't need to see them and you will always be there in a perfect condition because when you put it in the air, they are destroyed by the air actually. Okay, so I'm going to some projects. This is a building, 19 building. This is a landmark in Cyprus. It was 2016, the first high-rise building designed exactly how I told you. We measure, it is an energy efficiency A building. Look how it is working. This is what we call a decentralized geoexchange system. And why it is unique? Because it is decentralized. Before I show you a big heat pump. It's for a big hotel or for industry. Here, 100 small heat pumps. A heat pump for every office because this is sold. That means nobody wants to share a heat pump. They want to have their own heat pump, heat, cool, if the office is not, and pay for the electricity. So the system, it is something that we can do also in a town. In your towns, where you have a big desalination plant, you can create the same thing, a pipeline. We're now building the first island like that, and each one in the house is putting the heat pump there, and the temperature is going to the sea. That means that you have a decentralized heat pump, and as in Europe, in Germany, you know, they have the thermal, you know, the heat is coming from the town, from the power generation. So in our countries, the cool will come from the desalination plant. And everybody will put his heat pump on this decentralized cooling system. So this is a technology for our countries. It's not very well developed. It was a minister there. He said, why some things are not developed? Because the North Europeans, they don't care about it. So they don't develop it because you don't need a system like that in Germany or in Sweden. You need it in Greece, you need it in Morocco, you need it in the south. I give you many examples, but I don't want to. I think it's already the time is limited. I show you many projects here that have done combined projects, cogeneration, photovoltaics, geoexchange, all together. We go to a factory, we see what is the energy needs, and we make the plan. So we tailor-made what technologies we need to take the maximum efficiency, not only efficiency, techno-economical, what is more cost-effective. We want to see the total budget, how much money we save, and then we decide how big the photovoltaics will be, the cogeneration. So the size and the technologies are deciding not only because they are green, but because, for example, in this kind of factories, this is the biggest pasta factory of Greece and the third biggest in Europe, they care about production cost. And you have to persuade them what is the capex what is the OPEX, and you have to guarantee that because they have a production. And they don't pay only for green. They pay because they want also to have a payback, okay? So this is another factory, plastics, biogas plants with cogenerations. I can show you here factories with geoexchange, big factories for plastic production, and they use geoexchange and reverse osmosis. This factory is exactly like what I'm telling you. There is a borehole taking brackish water. They cool the engines, the extruders that they are producing plastics, and the water goes to a reverse osmosis plant and then goes down to a second drilling. So they cool the whole factory with geoexchange. This is 10 years ago, 12 years ago actually. When I go there, all the people, they say, are you crazy? Why nobody told us all that? It's so simple. They asked 15 engineers, a huge company, to try to persuade them for the very simple thing, that if you use the water, the cooling is very efficient. Because they couldn't believe it, that because they use air conditioning, they say, oh, it's difficult, you have to pump the water, everything will be destroyed, the heat exchangers will block. I say, guys, nothing will happen because you use low temperatures. We put a titanium heat exchanger, we are pumping, yes, almost seawater. We are reverse osmosis manufacturers. We don't afraid about seawater, we know it, okay? So if you use the right materials, you'll get the efficiency. Do you know what we have done in this factory? They measure how much kilowatt hours per ton of plastic they produce. They had the typical air conditioned, air cooled. We put electrical meter. How much we produce, how much kilowatt hours we have for the cooling. And they tell us, okay, you build your system now, and we measure again. If you fail, don't tell us crazy things. You tell us all about energy efficiency. Everything in the paper is perfect, but we want to measure it. We want to see how much kilowatt hours we have per plastic. And it goes, I promise 55%, they get 65%. And the contract was ESCO. That means that if we didn't achieve this, we will not get paid, okay? That was one of, then they expand to the whole factory. Now we're discussing about 5 megawatt. This factory needs 5 megawatt of cooling. So we're not discussing about small plants, okay? So I'm finishing wastewater treatment. This is a big factory of sausages and this kind of stuff. What we have done, actually, there is also a pig farm. So we take the effluent from the pig farm, UF reverse osmosis, and we provide water for the coolers, the cooling towers. They need water for cooling towers. And we told them, why you don't use the water from your sewage plant? And they say, no, it's very dirty, it will be very expensive, it's not the right quality. And it is a UF RO plant. And of course, we have done it also with very, very difficult effluent, so you can reuse. Leachates, reclamation. This is also something may also be affected. We have a special design. We developed it for more than 5 years with Hellas Gold, how you remove heavy metals. Because when they are taking they have to excavate, they have to take out the water. This water is full of metals. And you need a cheap way to take them out, a really cheap way. We are discussing about 1,000 cubic meters per hour, pumping the water just to keep the level, because otherwise you cannot take out, you cannot excavate, okay? But according to the authorities, when you take this 1,000 cubic meters and there are heavy metals, you cannot throw it to the sea, you cannot throw it to the river, you have to take out the heavy metals. And actually, in Greece, you have to take out the heavy metals to the potable water quality. It's crazy, because you pump water from the ground, the natural water, which naturally is contaminated, but they ask that you make it potable before you throw it to the river, okay? And this is a very special technology with glass, sand, activated carbon, and UF. It was tested for 5 years. Motor oil, I explained already what you are already doing. They are using, this is a huge geoexchange RO example. They pump the seawater, they use it for cooling. It passes from all the refinery. Of course, when it's coming to us, it's contaminated because it is already passing from all the refinery. You have metals, you have traces of oil, you have huge issues. We run this plant from 2007 and we develop the way you have to filter in order to do it. Believe me, it's not easy. We spend years to find the right combination of technologies and chemicals to deal with that. But what was the problem of the refinery? They increased the capacity, what you said, they couldn't increase the flow because they have to build a new, and they cannot pump more water. First of all, they don't have a license. Second, they need a huge amount of money to make a second pipe in the sea. So they say, guys, this is the water we have, and we need it. So you have to, not to increase the seawater, you have to use the seawater after we use it for cooling. This is for power generation. I will not have more. I think if there are any questions, I can answer to you. And I think that these things, it will be also very important to discuss it and try to see if you have similar applications. Because today I learned from you what you are thinking, and I think that you are learning also from us what we have done, so we can share this experience, which is very important. And thank you very much that you are appreciating your partnership and you can see the value on the strategic partnerships.
Thank you, Dr. Alex. So now we will listen to Mr. Patel from Ion Exchange.
Good afternoon. This is a very nice combination of subject which OCP and, yeah, I will not move. OCP and JESA has, plant. Sustainability and innovation, they are actually goes hand in hand. So we have a certain plans for the company and for the industry related to sustainability and the development and the innovations what we are doing in the products. So what is sustainability, in a business growth? Basically, if you say, it's a sort of a brand reputation and investors' confidence, because that's going to be the future for the next decade or so. The risk management and regulatory compliance, that is another thing. The third most important is customer satisfaction and motivating the employees as well as the productivity. The next comes is the quality, environment friendly, that's a main agenda, and the resource efficiency. The social progress, I mean gender equity and other things, and of course the inclusive growth. And then the last but not the least is innovations, the competitiveness and the business growth. So if you see the total sustained development goals by United Nations, there are 17 principles which are being done by the United Nations. And as of now, what I am presenting and what we are going to talk, these four main, it's mainly the number 4, which is quality and education, which is very, very important in today's world, because in a business, people forget about education, and which is very, very essential. The second is the green water, the clean water and the sanitation. That's another very important for the sustainability. And of course, the next is the innovations. And the last but not least is the partnership. Without that, you cannot go. The partnership with customer, partnership with vendors, and partnership with a lot of institutional, educational institutions which we are doing in India. We also have our sustainability vision as a company, and everybody has to follow that vision when we are sitting on our chair as the management. We have our own policy for the sustainability, which is signed by our chairman and managing director, and we have to follow it. We are displaying it so that all the employees, all the stakeholders, they know, along with the quality ISO policy, we also have the sustainable policy. Now, what is the strategy for the company in the sustainability? First is to maintain the leadership in the field in which we are working. As I said, stakeholder engagement. Now here, stakeholder doesn't mean only customer. It's vendor, it's the employee, it's the is the society, and also the shareholders for the company. Third is communication. We have to communicate to the stakeholders how the sustainability will be maintained and implemented by the company, and then planning and execution of this sustainable strategy which we have to do. And every time we need to improve on the sustainability strategies and monitor it, because every quarter as a business head, all the business head like me and other my colleagues, we have to submit the management, the policy and the implementation, how we are doing in our area of operation. That's what is comes as a reporting. Now, when you talk of the importance of sustainability and the ECG across the value chain, first is the access of finance. Of course, that's very critical. Reputation of the company, because when you implement all these sustainability factors, certainly your company's reputation in the society is going to go up. Then improved customer engagement. That's what we are doing now with JESA, OCP, as well as the other customers. Manage the regulatory board, the risk, because that is very critical, because we just don't want to supply something and which doesn't meet the regulatory board. So we always, as per our ISO policy also, we have to first check the regulatory requirements of various countries as well as in India. And we have to motivate our employees so that they give us the return, and of course the sustainable supply chains, because when we are selecting our supplier nowadays, like we used to have earlier, that if you supply ISO product, your supplier should be ISO. So we are now insisting to our suppliers, sub-suppliers, that they should also have these sustainable policies and they should display us what exactly they are going to do it. Now, when you talk of unlocking productivity through sustainability, it's basically renewable energy, which I will brief. Yesterday also briefed about the same thing. When it comes to waste management, it's effluent treatment, which we have been talking, all the speakers have been talking. Zero liquid discharge, we have now 35 plants in across the globe operating with zero liquid discharge. Then practice during the circular economy, in which you says reduce, reuse, refurbish, repair and recycle. That should be the motto. And of course the green supply chain management, that's again like employing the all the vendor and stakeholder, and of course the process and design optimization, which anyway we are number one in our field. Now what you talk of targeting energy, it's basically energy, and it's basically what again we have been discussing here. It's a sustainable shift, building green infrastructure that is becoming more predominant now, and reducing energy cost. My co-panelist also expressed a very nice thing about how they are done in the energy cost reduction. Now targeting efficiency with respect to material, well, that's very critical, because we should not waste and spoil the earth's the available resources. So what is more important is optimize the material utilization, optimize the equipment sizing, to capture the material flow and the causes of waste and emission, and we should go and talk to our sub-vendors, our customer, and how exactly it can be reduced. Re-engineering, which is very critical. In fact, that has become a more thing, and re-engineering as well as the value engineering, which is becoming part, and I'll certainly appreciate the JESA, which is involved in all this value engineering when we did the project with them. The recycling waste, and also using the automated system for reducing the time. Now when it comes to water, basically we have to do the audit for the water. We have a separate division, we called it Total Environment Solution, and their job is to go to various customers, do the water audit, which I think most of the industry they miss nowadays. The second, what is more important, is zero liquid discharge and resource recovery. I think that is critical, and basically air-cooled equipment, and the other thing which even now previous panelists also said. So what is business outcome this all doing? Actually, this will result in your reduced cost, it will be energy efficient, and also the risk mitigation will be done because of all this if you do it very nicely. Now what we did for the alternate energy, I will just brief, and couple of innovations we have done for the energy as well as the water saving. The first very beautiful thing which we did is we used solar water for the reverse osmosis plant. We have supplied 12 plants in Abu Dhabi to the government of Abu Dhabi for operating the reverse osmosis plant. So they are all, it's all by power by the solar power. We are now working on high recovery RO. As you know, we are manufacturing reverse osmosis membrane also. So a lot of research is being done for the recovery of the RO plant, and which Mr. Buzian also spoke in his world. Well, some different application for reverse osmosis, but maybe it is very useful for the audience here because I am not really aware Morocco's situation with respect to the kidney. But we have done a lot of innovations by using reverse osmosis membranes for the kidney dialysis. It's called AKD, we call it. It's automatic kidney dialysis. And now in India, a lot of people don't go to the hospitals, they go to the kidney center for doing the AKD, and this we are supplying to a lot of international company in their brand. But I thought, being we are talking innovation, so I'll just add one slide on this. So this is a small model, how exactly, and the people are now, the smaller version is also available, so people do home kidney dialysis also. Of course, I will go this fast. Now we did also to save the water, another product, since we manufacture the ion exchange resins. As many of you may be knowing that normally any of the water treatment 2-bed system, you need a 12 or 14 hours or a 24-hour cycle. But this innovation, you just need 3 hours running of the plant. In 25 to 30 minutes, you totally regenerate the plant. So it's a special kind of resin, and this saves a lot of water when you do the regeneration. Otherwise, that is a major concern for all the 2-bedder systems. I'll just go. We have also done new innovations. This is our own and patented technology. We have mixed, it's a combination of plate clarifier and the conventional circulation clarifier. So it takes almost 1/5 of the space which is required. You will require very less chemicals, polymers and etc. so that your overall, the consumption of water etc. is saved. In fact, in Indonesia, one of the biggest paper mill company here, our plant is operating at 750 MLD. It's a very huge plant. And there are both the paper mills in India. Paper is a big product of Indonesia, and all the paper mills here, they use this technology. And the next one which I'll show. So last 15 years, they are only following with ion exchange, and our service people are, they're all here so that we treat this. But this is a very good product, and you get directly the water in Indonesia having a lot of colloidal particles. So with one stroke, without filter, you get conductivity, the suspended solid much than 0.5 ppm. This is another product which we have done, which can be used for Morocco. It's again a combination of plate clarifier and the filter at one unit. So I will show you some photograph. So this is a small unit which can go to the remote villages of Morocco, where there is no pure water and no need of reverse osmosis, high salinity water. It's sort of it's a filtration unit. It can be lifted by helicopter, or it can be carried by the truck. It can go to a small villages, and it is mainly used for the society, so that they get a good drinking water for their thing. This is another thing which we have done, filter pack. This time we had proposed this to JESA for the upcoming project, where you don't need a power to backwash whole of a plant. Again, this plant of 500 MLD is working in Indonesia with no backwash power required. We use the head of the complete equipment to backwash whole system, and it's again giving fantastic results. So you can see here, the filter pack, the inlet is 25 and you get 1 ppm, and there is nothing required as such, no operation for the plant. Of course, the lot of advantage, and I can share the detail which we have done. This is the proven product which we have developed ourselves in our factory. Well, ZLD we have been talking yesterday also I spoke, so I will not touch more on this. Yesterday I briefed about this. So this is a part of innovations we are doing by using various technologies for the zero liquid discharge or recycle. And our aim is to have that we should give back whatever we have learned from our experience in the field, from the customers, and give back to the society by way of saving water and energy. So this is again establishment in our own factory where we have implemented ZLD and recycle. So that's all from my side. This is regarding sustainability and innovations. Yeah.
Thank you, Mr. Pata. So now I will ask Mr. Igor to share with us all the effort about innovation in Fluotech.
Hello. Thank you all for your assistance today. Well, I will focus my speech mostly on one single product, one single equipment that is not an innovative technology itself. It's more like an innovation regarding how to use existing well-proven technologies, like in this case the ultrafiltration membranes. Okay, this is directly related with the plans of OCP and JESA in Morocco, because indeed in Morocco the main pretreatment they are implemented in their seawater reverse osmosis plants is the ultrafiltration. Well, coming back first, the title of the presentation is Less is More. It's a way to explain how with something that can look simple from the outside, you can achieve more advantages, and you can even break the current existing boundaries of the UF we have all known so far. I will explain how this IUF technology that the I comes from integrated can minimize the footprint and also the efficiency when talking about new installations or even retrofitting all plants with new technologies shifting to ultrafiltration. Well, as I mentioned, the I comes from integrated. This is the integrated ultrafiltration, and the concept is merely a pressure vessel that is manufactured in FRP material, that is a non-corrosive material suitable for seawater. This is a pressure vessel, so it means that this is designed according to international standards of pressure vessel manufacturing, like the ASME or others. Being FRP, this can be installed outdoors, so the possibilities of using this equipment, this is innovative approaches are huge, and this can offer different advantages to both EPCs and end users. Advantages like reduction of the project's capital expenditures, as well as the significant reductions in the project's lead times. Decreasing as well the necessary civil works or building areas, and for the end user can also provide with some significant advantages. Okay, the concept of integrated comes from the integration in the same pressure vessel of two stages of filtration. One is the self-cleaning strainer, and the second one is the ultrafiltration membranes. Everything packed in a single canister. The first step is the coarse filtration or the automatic filtration that is in the bottom part of this pressure vessel. The water enters from the inlet flange connection and will flow from the inside to the outside of the automatic strainer that will typically have a micronic cut of in something around 150 or 300 microns, depending on the membrane. In this case, as we are using DuPont's membrane since some years ago, we are always using something in between 150 and 300 microns. The second step is the ultrafiltration that is in the upper chamber. So once the water has flowed from inside to the outside in the automatic strainer, the water will flow upwards to the second chamber and will start being ultrafiltrated by the ultrafiltration membranes. The backwash offers the possibility of backwashing both the UF and the strain at the same time, or even independently, depending on the requirements and the water quality of each project and each plant. The components, mostly three. The pressure vessel, as I mentioned before, in FRP, because it's our competitive advantage and the most suitable for dealing with seawater. But this can also be manufactured in other materials like stainless steel, carbon steel, or other alloys if necessary. The screen, or the automatic screen, as mentioned in the bottom part, and the membranes. The membranes are the same, the hollow fiber polymeric membranes are the same, outside to inside, PVDF material. So being the same membranes, I would like to reiterate that it's the same membrane, so it's the same performance that you will achieve with the conventional skid. We all know that the conventional ultrafiltration modules are packed in PVC housings or polyethylene or other thermoplastic material cases. This means that there are some limitations in terms of the usage of these modules. The FRP material is a thermoset one, while the PVC and other alternatives available in standard shape in the market are thermoplastics. The thermoplastics do not behave properly against a combination of heat and pressure. So this means another huge advantage for the FRP that can be installed outdoors and can withstand higher pressure ratings, thus offering the possibility of playing in a more smart way in your favor when developing new projects or when trying to retrofit existing old installations. As you can see in the picture, well, this picture is from a cartridge filter platform installed in the nearby the sea in the beach in Saudi Arabia, and well, you see that this doesn't require a building to cover the housings, the equipment from the direct sunlight. This installation is an example of FRP pressure vessels installed outdoors under the direct sunlight for more than 20 years in harsh atmospheres. So this demonstrates that this is not only long-lasting, but also offers you the possibility of installing the UF in places that before could not be done. Another advantage of this innovative approach is the compactness of the system. We can achieve a huge compactness compared to other existing systems, of course, thanks to the combination of the auto strainer and the UF in the same pressure vessel. This means that instead of having two systems or two states separated, forcing you to have a huge footprint, in this case, you are maximizing the compactness of the new installation or the new installation. There are some comparisons here that I don't want to enter into detail, but I would be glad to share all this presentation with you after this if you contact me, so no problem for that. I will go straight forward to the UF example for you to check a real one. Well, this is an example of a project in which it can be seen that the installation is outdoors. The corrosion resistance is perfect because, as mentioned before, we are using composite materials. Having a composite material as a pressure vessel can allow you to do a direct coupling in between the reverse osmosis and the UF and the reverse osmosis high pressure pump. This means that you can save the storage tank and you can also save the pump. You can save footprint and you can save some investment on the tank. The tank is usually huge for this kind of capacities that we are talking about, and also the transfer pump can be avoided. Thus, you can save some energy as well as also some money there. This provides with a simple installation. This allows you to do super fast track projects, and when you have a footprint restriction, all this combination, when we put all this together, we can really see these advantages provided by this innovative equipment or approach. Well, in this project, we delivered a total of 81 pressure vessels with 61 modules of 52 square meters area each, totaling 150,000 cubic meters per day. And well, our role in this type of projects can be different, but at the same time very similar to the ones I explained yesterday in the other presentation. We can start with the process design, the detail design, to the manufacturing. What we are doing is to combine our proprietary technology, our genuine technology that is patented by us, with existing membranes, for example, in this case, the DuPont. So this way, what we achieve is warranted performance and the same performance as in other conventional systems, just benefiting from all the advantages that this technology can bring us. This is mostly everything I wanted to explain to you. And if you have any question, I would be glad to enter deeper in detail, of course. Merci beaucoup.
Thank you, Mr. Eagle. So I don't know if there is any question. Yeah, I guess so. You have a question for our partners. Yeah, go ahead.
Mr. Rigo, thank you for sharing the new technology for the UF. I have two questions. The first one, why the IUF filtration can be outdoor and the classical ultrafiltration no? You must be in building. First one. And the second one is about energy consumption. If we compare the classic ultrafiltration and the eye ultrafiltration, who consume more in electrical energy?
Yes, first about the outdoors installation. Okay, typically the conventional UF modules are installed inside a pressure vessel that is made of thermoplastic. This thermoplastic material can be installed outdoors, but you need to cover it with a roof or something like that, or they need a shadow to avoid the contact with the direct sunlight. Okay, because this can damage the resistance of this small pressure vessel. It is true that the conventional modules are small, and the pressure resistance of them are usually in between 5 to 7 bar. But when these are installed in high temperature atmospheres, the pressure resistance of the same will decrease as long as the heat increases. For example, a conventional UF module, PVC one, may withstand up to 7 bar. Perhaps it is too much, but let's say 7 bar at 20 degrees. But it's not the same as 25 degrees, at 30 or at 35 degrees. Okay. Also, the sun can damage the PVC material, deteriorating the mechanical resistance of the same. This regarding the outdoors installation. And the second question, sorry, you can.
Electrical consumption.
The energy consumption. Well, when you are packing 2 stages of filtration in the same pressure vessel, you are getting rid of a lot of pipes, interconnection, and manifolds. So the friction is lower, and this means that the pressure is decreased, so the energy consumption is slightly lower. It's not.
What-
it's
what
not
the
that
saving?
significant.
What the saving?
The saving is not. I can share with you presentations with comparison of the energy savings. It is always less consuming than a conventional one. Always. It is not really significant. It will not be a game changer in your total consumption of the plant. But in these installations, every single drop counts, and it is very easy to understand that when you are getting rid of a lot of manifolds, elbows, and connections and pipings, of course you achieve a lower energy consumption.
Thank you, Mr. Igor.
Is there any question? So thank you so much. Thank you, dear panelists. Thank you for attendees. And see you the next forum. Thank you.